Greetings, friends. In this short video, we're going to demonstrate how to use this particular website, this VassarStats.net website, to compute the basic kind of stats that we'll be using in this class. Specifically, we'll be talking in this video about independent and paired samples t-tests. You might have noticed that I referenced a program called SPSS throughout the course. Well, since I recorded those videos, I found this website that does pretty much the same thing. SPSS is obviously a bit more powerful and more expensive as well than this site, but this site will get the job done for us. The site is VassarStats.net, VassarStats.net. And you get to that site and you'll get to this main page here. And along the left-hand side, you will see various statistical procedures that you can select from. For this presentation, we want to use the t-tests. What we are going to do in this video is demonstrate independent and correlated samples. Correlated is another word for paired samples, so you can say that this video is about independent or paired samples t-tests. You'll click on that link and you'll see a dialog box that looks like this. Sample A and sample B, because we're comparing two groups. And what you will do is you will go ahead and put your data in these two boxes. Now you could just enter the data manually and hit the return key. Make sure you don't hit the return key after the last item in the list. Or you can, if you already have put the data in spreadsheet form, you just go ahead and copy the data from a spreadsheet and put it in sample A and copy and paste to sample B. Now, once you've done that, you select which analysis you want. We want the correlated or paired samples because these are scores from a pre and post test. So we click that and hit the calculate button. So you hit the correlated samples and calculate button, and then you'll see all these boxes below, the results of the calculation in them. There's a lot of numbers here, and if this was a stats course, we would go through all of them. For our purposes, I'll just point to the ones that you need to know. This N right here, that's the number of items in each sample. There are 15 items in sample A, 15 items in sample B, and so the total number of N for the entire analysis is 30. We want 15 and 15 in each, well, 15 in each group. The next number that you need to take a look at is the mean score or the average score for each group. I suggest that you just use one decimal point, 39.8, 73.1. And then the other statistic that's important is this one right here. And this box here shows you the p-value. Now, the p-value tells you whether your results are statistically significant or not. And you might remember from the other video that in order for a statistic to be statistically significant, it has to be less than 0.05. And in this case, the results are less than 0.05 for a one-tailed test and 0.05 for a two-tailed test. And the difference between those is the difference between whether or not you know or believe that that one group will have a higher or lower score than the other. And if you have reason to believe that, let's say that you were doing a pre and post test, you would reasonably expect post-test to have a higher score than the pre-test. You know that by the design of the experiment. If that's the case, then you are just looking at a one-tailed result. And think of the one tail as referring to the bell curve, and you are interested only in results that are on one side or the other of the middle of that curve. If you really don't know in advance whether the results would be higher or lower from one group to the next, then you would use this, the two-tailed result. So if one or the other, depending which one it is less than 0.05, you have a statistically significant result. Now, just because you don't have a statistically significant result doesn't mean that your time and efforts have been wasted. A lot of times you don't want a statistically significant difference between the groups. Say, for example, that you are working with a group that normally doesn't perform as well as another group. Maybe some gender or ethnicity has historically underperformed another group. Then if you found out that those two groups were performing at the same level of effectiveness, then that would be a good finding. You would not want the differences to be statistically significant. So that's for a correlated or pair samples t-test. We'll go ahead and reset that. And now we want an independent samples t-test. The process would be the same. You would just highlight on a spreadsheet or enter manually results from one group and the other. Now notice that in this case the groups don't have to be the same size. Paired samples, obviously they do, because you're studying the effect of a group or the effect of an intervention on a group, and you want to know what individuals received the first time and then the second time that they were tested. And here these are two totally different groups, and so you wouldn't have to have the same number of items in each sample. In fact, you almost invariably won't. If you were studying two different ethnic groups or gender groups, chances are those groups would be unequal, and that would be fine for our purposes here. Independent samples is checked, and you go to calculate. And the boxes are the same. Here's your N for one group, and here's your N for the other. One-tailed and two-tailed significance. Now, I made sure that these numbers were different enough that you would get a result that was statistically significant to show you how that worked. But again, as I mentioned, it wouldn't have to be in order for the results to be important. Once you're done with this, you would go ahead and you would write the results up, and I've referenced this before in another video. But just to let you know that all these numbers, most of these numbers would be from the analysis that you just created. The N, that's the number. That's this number right here. The N is capital N here, small n here, but it means the same thing. And then the M is the mean score. You just report that. And so this is how you would write up the results. This is all you would need for our purposes. In another video, we'll show you how to write up the effect size. But this is how you write results for an independent samples t-test. And this is how you write the results for a paired sample or correlated samples t-test. In another video, we'll show you how to do an ANOVA, which is the difference between 3 or more groups. But for our purposes here, this is all we need to know for running the very simple kind of a t-test.